Hello and welcome back to part 2 of section 1.5 of geometry. Let's now complete the example problems together. Real world example 1, identifying angle pairs. From the diagram with the cheerleaders, we see many lines could be drawn. Name an angle pair that satisfies each condition. We want two acute adjacent angles. Two acute adjacent angles. So looking at the diagram here, this would be an acute angle here. That doesn't show up very well. I need a maybe orange. Nope. Pink. Pink shows up better. That's an acute angle, but it's not adjacent to any other acute angles. So I'm going to go down here. There's one. So OJN. And angle, the one right next to it would be NJM. NJM. All right. How about two obtuse vertical angles? This one's kind of easy. There's only two obtuse angles in the whole thing, and they are of wait, hold on. They have to be vertical angles, which means they have to be made by intersecting lines. The ones I've just highlighted are not intersecting lines. This is the line. That is the line. Okay, careful with that. So we need angle HJN and angle KJM. Okay. Example 2, angle measure. Find the measure of two supplementary angles if the difference in the measures of the two angles is 18. Okay. Well, we know, let's take down what we know. Let's come up with some angles here. Shall we call them A and B? We'll call the measure of angle A, we'll just call that little a. And the measure of angle B, we'll call little b. If they are both supplementary angles, that means the measure of angle A plus the measure of angle B equals 180. And the difference is 18. So measure of angle A plus the measure of angle B. No, we just did plus. Difference minus measure of angle B equals 18. So we can turn that into a system of equations. A plus B equals 180, and A minus B equals 18. Let's use a good old substitution here. We will, if A plus B equals 180, then A is equal to 180 minus B. And I'll substitute that into the second equation. So 180 minus B equals 18. Okay, A plus B equals 180. That means A equals 180 minus B. And then substitute that into there. And so we have 180 minus B minus B. 180 minus 2b equals 18. Subtract 180 from both sides. Negative 2b equals 18 minus 180 is going to be the opposite of 180 minus 18. 180 minus 18 will be slightly more than 180 minus 20. 180 minus 20 would be 160. I didn't subtract 20, so I gain an extra 2, 162. opposite, negative 162. Divide both sides by negative 2. Half of 16 is 8, half of 2 is 1. 81. And that means B is 81. That means A equals 180 minus 81. Oh, geez. If it was minus 80, it would just be 100. So minus one more. A is 99. Okay, I have B. I have A, so we can return to the original designations. The measure of angle A equals 99 degrees, and the measure of angle B equals 81 degrees. Final answer. Example 3, perpendicular lines. I'm going to move my diagram over a little. What? Don't take the box with you, really? I'm not going to move my diagram. I'm just going to leave it as is. Find x and y so that line PR and line SQ are perpendicular. X and y. Okay, so from knowing that they are perpendicular, I know that something must be 90 degrees. And actually, looking at this, okay, line P, R, and SQ, we can do two different things. I would know that they're perpendicular. That's 90, that's 90, that's 90, this is 90. Let's do, I think y is going to be the easier one first, because that's already labeled there, 4y minus 2. So I know the 4y minus 2 must be 90 degrees. Add 2 to both sides. Divide by 4. Half of 90 is 45. One more makes it 46. Half of 46 would be 23. So y is 23 degrees. And over here for x, we would have to combine these two together. Let's switch back to blue. These two together form this right angle. So 2x plus the 5x plus 6. Is equal to 90 degrees. 2x plus 5x is 7x plus 6 equals 90. Subtract 6 from both sides. 90 minus 6 would be 84. And 84 divided by 7. 7 times 3 is 21. 21 is a fourth of 84. So times 3 times 4 times 12. X equals 12 degrees. And that is what they wanted, x and y. So I'm going to just put a box around this as well. That is my final answer. There were no further steps. There we go. And then example 4, interpreting the figure. Look at all this stuff marked up on the diagram for us. How convenient. Determine whether each statement can be assumed from the figure. Explain. Okay, we've got, I think I will try to move this a little bit closer here so I can zoom in a bit. Angle KHJ. I like highlighting as I go. Angle KHJ and angle GHM are complementary. I'm not, wait, J, KHJ, yeah, and GHM, yeah, no, I'm not seeing that. I see they're congruent. So I'm going to say new. I don't see that. No. The angles are congruent but they do not form a right angle. Remember, complementary means add up to 90 degrees, aka right angles. These two don't do that. At least they don't appear to. Maybe they're poorly drawn, very small drawn 45-degree angles, and they do, but you can't tell from here. That's what we're looking for. What could we definitely guarantee from here? Next, angle GHK. GHK and angle JHK are a linear pair. Well, seeing as this is a straight line and they share a side, it's the one highlighted in green and pink there. Yes. So, yes. Why? They are adjacent angles that form a straight line. Good. How about ray HL? Reset the highlights there. Ray HL there is perpendicular to ray HM. HM right there. Well, you see, there's a little 90-degree angle in the corner. So yes, they are perpendicular. Yes, they are perpendicular. Because what is that angle? MHL? Yes, angle MHL is a right angle. So we know they must be perpendicular. Good. And that was it. That's all for examples. This concludes the example problems for section 1.5. So long, farewell, enjoy the rest of your day.